Hello dear friends, once again we are discussing a new method in differentiation, which is the method of parametric equations. See friends, as you see, one thing you have to remember that for parametric equations we have two equations in which we have more than two variables. I have written here as x equal to f of t. That means x is the function of variable t. X is also a variable. Again, y equals to f of t. Again, y is also variable and t is also variable. And in equation in which parametric equation is there, we will find dy upon dx with t as their common parameter, because t is in the equation of x also and in the equation of y also. So remember, whenever there are more than two variables, as in this equation we have three variables, more than two. These are x, y and t is their common variable as a parameter. So these are called parametric equations. Now to understand better, let us take another example. See, in this question we have x equals to a cos theta and y equals to a sin theta, and we need to find dy upon dx, the derivative of y with respect to x. But as you see, the equations have a common parameter, which is the third variable, which is theta. I have shaded it in the yellow form. You can observe x and theta as variable in first equation and y and theta in second. Now to solve such type of questions, it is very easy that you find the derivative with respect to that parameter. Say here x equals to a cos theta, so we take dx upon d theta, variable x with respect to variable theta, which is a as it is, and cos theta derivative is minus sin theta. You remember that. Again, on the right side we have variable y equals to a sin theta, so we have dy upon d theta equals to a as it is, because it is a constant, and the derivative of sin theta is cos theta. Now we need to find derivative of y with respect to x. So observe this formula. Dy upon dx is dy upon d theta into d theta upon dx, because automatically d theta cancels out and you are left with dy upon dx. But this is the trick, or this is called the parametric method to solve the differential equation. So put back the values. The value of dy upon d theta was a cos theta into the reciprocal of derivative of x with respect to theta, which is minus a sin theta, but we take the reciprocal, so it comes to the denominator, that is minus a sin theta. A cancel out, and so you get minus cos upon sin, which is cot theta. This is quite easy. So only one thing to remember is take the variables with respect to another variable and take derivative of y with respect to x. Let us take another example. Say x equals to a into theta minus sin theta and y equals to a into 1 plus cos theta. Again, equation has x and theta as variable on the left and y and theta as variable on the right. So we take their respective derivatives. So dx upon d theta becomes a as it is, because it is a constant, and the derivative of theta with respect to theta is 1 minus derivative of sin theta is cos theta. On the right side you see derivative of y with respect to theta is equal to a as it is being a constant, and the derivative of 1 being a constant is 0, and the derivative of cos theta is minus sin theta. So finally we need dy upon dx. So we write dy upon dx equals to dy upon d theta into d theta upon dx. Or you can say we have taken the reciprocal of dx upon d theta. So put back the values, which are a into minus sin theta upon a into 1 minus cos theta. So a cancel out, and you are finally left with minus sin theta upon 1 minus cos theta. So this is quite easy. Let us take another example, a bit complex but not difficult. Now friends, here you observe on the left this is variable x, and on the right instead of theta we have taken the variable as t. So the variable may change, you need not worry about that. So first of all, x equals to a into cos t plus log tangent t by 2, and y equals to a sin t. Now dx upon dt, because the variable is t. You will not write dx upon d theta, no, because on the right side the variable is t. So we will write dx upon dt. So a as it is being a constant, in the brackets the derivative of cos t is minus sin t plus derivative of log is 1 upon the function is tangent t by 2 into chain rule. You remember derivative of tangent t by 2 is secant square t by 2. Again chain rule, derivative of t by 2 is 1 by 2. So dx upon dt is a into minus sin t plus secant square t by 2 upon 2 tangent t by 2. This was dx upon dt. Now we take the function y equals to a sin t. So dy upon dt becomes a into derivative of sin t is cos t. And using the parametric method, we write dy upon dt equals to dy upon dt equals to a cos t upon a into minus sin t plus secant. Friends, it should be here dy upon dx. See, because we have divided derivative of y with respect to t with derivative of x with respect to t. So it should be dy upon dx. So friends, this is how you solve the parametric type of questions in differentiation. And for any queries or any difficulties, you can always ask us. Thanks for your response. Please like, share and subscribe my videos. See you in the next video. Bye bye.